dealing with the right triangles. We're still using the SOHCAHTOA, all of that, but we are going to be finding all angles and sides within a triangle. So it's not just only nice, pretty ones that we have a hand trick for. We're going to be looking at all kinds of angles now. So you will need a calculator. Go ahead and make sure it is in degree mode before we do anything else. All right, so first thing we have is just a definition. We are going to be talking about significant digits in this. So you might have seen some significant digits in your science classes. When I'm looking at significant digits, we are going to be finding it using some very specific rules. I know Mrs. Delacourt does significant digits, and our rules are just slightly different than a couple of the things she does. We count all the digits from left to right, beginning with the first non-zero digit on the left. So you start on the left, the first digit that isn't zero, and count there. If there is no decimal point, we do not count the trailing zeros. Significant digits. So if I'm looking at this one, so look at the definition you just wrote down. We start where? On the left. And we begin with what? The first non-zero digit on the left. And then we don't count trailing zeros if there's no decimal. So first non-zero digit on the left is what? 4. So how many significant digits do we have? 2. What about B? How many significant digits does it have? 1. What about C? If the 0 falls between digits, we still count it. So this will give us a total of 3 significant digits. Okay. D. The first non-zero digit is 6. If there's a decimal, though, we do count all the zeros after it. So how many significant digits here? E. How many significant digits? There's a decimal, so we do count all those zeros. 5. So there's 5. Now F is different because there is no decimal. So the first non-zero digit is 7. Trailing zeros, if there's no decimal, we don't count those. So this only has 1 significant digit. Now how we are going to be using this is sometimes I will tell you to give your answer in terms of significant digits. Basically, if you can't be more accurate than the numbers that were originally given to you. So if every number I gave you was rounded to the nearest 10, could you give me an answer that was correct to 3 decimal places? No, because your original numbers weren't correct to 3 decimal places. So I will be very specific. Today, everything we're doing is significant digits. When it comes from anything beyond today, I will tell you, give 3 or use the number of significant digits for your answer. If I don't tell you that, then we'll go with our standard 3 to 4 decimal places like I usually do. So I will tell you when I want significant digits. When we are looking at triangles, we will try to make sure all of our sides have the same number of significant digits and all of our angles have the same number of significant digits. So a few assumptions that we are going to make from now on. If I say right triangle ABC, you can assume that C is the right angle unless I tell you otherwise. So so I'm probably not going to keep saying C is the 90-degree angle. We are just going to assume that. We will round our answer so the number of significant digits matches the least number of significant digits given in the problem. So if one number I gave you had 2 significant digits and another had 3, your answer would have 2. So you have to look at the least precise number they gave you, and you base your answer off it. And finally, we don't want to round in the intermediate steps. Every time we round, it throws off our answer a little bit. So if you have a 4-step problem and you round 4 times, your final answer is really far from the original. So we're only going to round at the very end when we are going through these. All right, so the rest of the day today, I'm just going to have examples where I give you different pieces of information, and we are going to find some sides and angles from that. I have lots of examples. I will do as many or as few as you guys need. So you just have to tell me as we go through them if you understand or not. So let's look at number 1. In right triangle ABC. So I'm going to stop right here. I have a right triangle. And I have told you from now on, unless I tell you otherwise, C is my 90-degree angle. Angle A is 40 degrees. Side C, so we know that's across from angle C, is 12. And I want to know what side A, side B, and angle D are. So here's side A, here's side B. What would be the easiest piece of information to probably find here? Angle B should be pretty easy. We know that in a triangle, all the angles add up to 180. If this one's 90, 180 minus 90 is 90, so the other two have to add up to 90. So if this is 40, what's angle B? 50 degrees. All right. We're good there. How many significant digits did 40 degrees have? 1. 50 degrees also has 1, so those match. My sides, how many significant digits does my side have? 2. So we're going to go ahead and give sides A and B correct to 2 significant digits. So I just try to keep the angles the same and the sides the same. All right, for side A, we did some like this on our quiz, except they were with values we knew. We did a trig function. So from angle A, side A is opposite, 12 is my hypotenuse. What trig function? So I could say that sine of 40 degrees equals opposite over hypotenuse. Now we were used to on the quiz, it was like sine of 30 or 45 or 60, something I knew from my hand trick. I don't know the sine of 40. So we are going to use our calculator. But I don't want to use it yet because it's going to be a decimal that never ends and I don't want to round until the very end. How would I get A by itself? Multiply by 12. So now I can use my calculator. So I'm going to do 12 times the sine of 40 degrees. And the answer I get is 7.7135, but how many significant digits did I ask for? 2. 2. So what would you answer?
7.7.
And I told you my side was in centimeters. All right. When we are doing these, I want to caution you a little bit. We have, using significant digits, we have more rounding error than we are used to. That means if you do Pythagorean theorem versus a trig function, your answer could be off by a decimal because we are rounding quite a bit. As long as you have the work to show me how you got to your answer, it's okay. All right, so it's just going to be, because we're rounding so much, especially if I were rounding to like 1 significant digit, you know, you might get a different answer if you use a trig function with the side 12 versus side with 7.7, just due to all that rounding error. So please just show me the work to justify what numbers you're getting. If I wanted to find side B, let's say I wanted to do a trig function. And I like to use the numbers given in the problem whenever possible, just to help eliminate some of the rounding error. So if I want to use angle A, B is adjacent, 12 is hypotenuse, so that would be, let's say the cosine of 40 degrees equals B over 12. So multiply over your 12. You get 9.1925. But if I said significant digits, we would call this what? Is that one okay? Do we need another problem where I give you an angle and a side? You can just subtract to get the missing angle, trig functions to get the sides. Let's say I gave you this one. What information am I giving you this time? A and B. I'm giving you two sides. I didn't give you any of the angles. Now we know we have a right triangle ABC. And we are assuming that C is the right angle now. So side A was 2.73. Side B is 3.41. How many significant digits am I using in this problem? 3. Find the remaining angles and sides. What would probably be the easiest way to get my remaining side? If I've already given you decimals, then you can use decimals for that last side. Okay? So A squared plus B squared equals C squared. And to get C, we're just going to add the square root to each side. So I'm going to go to my calculator. Square root 2.73 squared. So if I round this to 3 significant digits, what would my answer be? I didn't give you units, so we can't really give a unit there. Now, we have to figure out how to get these angles, which is a little bit different. We haven't really had to do that before. I know angle C is 90, but we can't do SOHCAHTOA from the right angle. So let's say I talked about angle A. 2.73 is opposite, 3.41 is adjacent. What trig function involves opposite and adjacent? So I could say tangent from angle A equals 2.73 over 3.41. Now we have done problems similar to this when we talked about using our calculator. How do you separate the tangent from the angle? If I need to move this tangent to the other side, what do you have to change it to? Had it on our quiz, had it on our review handout. We're looking for an angle, so what do we have to do? Oh, come on, guys. When you're trying to find your angle, that's when you did the inverse. and since this is an angle, what should my label be?
Degrees.
This is an area where you might get a slightly different answer for the other angle depending on how you do it. And we know the angles always add up to 180, so if you do 180 minus 90 minus the 38.7, so I'm really just going to 90 minus 38.7, and I get 51.3 degrees. If you had done, you could have also done like tangent inverse of B from angle B, so B is tangent of 3.41 over 2.73. Sometimes, just because of the rounding error, like I said, those numbers might be off by a decimal place. This one, they do turn out the same. Just make sure you're showing how you get that. It's also possible that depending on what approach you take, your angles may not add up to 180 exactly. It might be 179.9 degrees or 180.5 degrees, just because we're rounding so much within the problem. So please, 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 just show me the work for how you're getting to your answer. Any questions there? So when you need an angle, that's when you have to do an inverse. Why don't you guys try one? And we'll go with this one. I'm not asking you to find everything on this one. You just are asked to find one particular angle. You guys have it set up like this. And all we had to find was angle B here. So from angle B, these sides are my what? Opposite, adjacent, hypotenuse, what are they?
Adjacent.
Adjacent and hypotenuse. What trig function involves adjacent and hypotenuse? So I could say that cosine from angle B equals my adjacent side, 3.32, divided by my hypotenuse, 45.5. Then how do I get the B by itself?
Reciprocal.
B inverse. So that's second cosine. And we get 59.1977. How many significant digits did we have in this problem? 4. So that would take you get 59 point, the 19 would have to round up. So 59.20. Or not feet, we're in angles, so degrees. Why did I put the 0 on the end? If I just put 59.2, how many significant digits is that? 3. But if I put 59.20, that gives you a 4. Now, sometimes it will be impossible to match the number of significant digits. For instance, if, let's say you got 9 point, let's say, okay, if we had this. If I asked you to round that to 3 significant digits. Okay, so 1, 2, 3, but what's that 9 cause it to do? Round up. If I write 100, how many significant digits is that? That's only 1. If I put 100.0, how many is that? 4. And I said 3. So is it possible to give 3? If it's not possible, you have to go with the smaller number. So I would have to go with the 100. I just can't give more significant digits than the problem allows. Let's talk about angles of elevation and depression. So the key to these, they start from a horizontal line. So an angle of elevation starts from a horizontal line and goes up. Angle of depression starts from a horizontal line and goes down. The angle of depression from the top of a tree to the point on the ground, 15.5 meters from the base of the tree, is 60.4 degrees. Find the height of the tree. Right, this is kind of confusing if you're just looking at it, but let's try to draw a picture. So we've got a tree here. Alright. Angle of depression has to start at a horizontal line. So I need to draw in a horizontal at the top of my tree. And then from there it goes down. We are talking about a point on the ground. So from this horizontal line down to a point on the ground. This angle is 60.4 degrees. I am trying to find the height of the tree. So we'll look into this. And we know the point is 15.5 meters from the base of the tree. So I know this distance. Okay, first thing, if we're going to use any trig functions, what kind of triangle do we have to have? A right triangle. Is this a right triangle? Yeah, it should be. If we're talking about a vertical and a horizontal, that would make a right angle right here. Okay, do I know any angles inside my triangle? The 60.4 is outside my triangle because it's from the horizontal going down.
That would from the other side.
Okay. These two together should make 90 degrees. So 90 minus 60.4. If you're a geometry person, you could have also thought about alternate interior angles. If this is 60.4, this angle down here is 60.4. So either way, we just need one of the angles inside our triangle. So from here, if I'm using this angle, 15.5 is the opposite side and x is the adjacent. What trig function is that? So let's say the tangent of 29.6 degrees equals my opposite side, 15.5. Divided by my adjacent side, x. Okay, I'm trying to solve for x, so you have to multiply by what's on the bottom of your fraction. Then how would you get x by itself? You have to divide the tangent over. So now I put it in my calculator. 15.5 divided by the tangent of 29.6. How many significant digits do I need to give? 3. So we get 27.28, so that would be 27.3. It's the height of the tree. My height on this problem was measured in meters. Any questions on that one? Let's try another one. feet tall is 27.65. So what should I do here? We've got a flagpole. Okay, I know that flagpole is 55.20 feet tall. Where does the shadow go? On the ground. 27.65. We can assume that the flagpole is standing straight up, so that would be a right angle. I want the angle of elevation of the sun. So we know the sun is up here. Angle of elevation starts at a horizontal and goes up. Isn't my ground a horizontal? So if I'm starting there and going up, I'm just looking for this angle right here. So this time, the angle is inside my triangle. What trig function would we use there? Tangent of angle theta equals the opposite side, 55.20, divided by the adjacent, 7.65. Then if we're trying to find the angle, to move the tangent, we make it tangent inverse. How many significant digits? Okay, so that would be 63.39 since it's my angle that is in degrees. Questions so far? Let's stop here for today. We are not done with the section. We will finish it tomorrow. So right now, we are ready for I'm gonna go ahead and put all of them up here. Technically, you should be able to do all of these. The last few are the angle of elevation and depression problems. We will do some more practice tomorrow. So you'll have some time to work on this. We'll do some more examples. And then I'd also like to do one of the tables quizzes. We're just gonna rack up some quiz points. So remember last week we did sine, cosine, and tangent for the hand trick. And I wanna give you the entire table tomorrow to make sure we know that, because we have probably a test next week, and that's gonna be the first page of your test. It's just that